All right, this is lesson 4, solving systems by elimination today. So we've learned so far, maybe I'll just write this down here. So far in lesson 2, we solved by graphing. So that was one way you can solve a linear system. In lesson 3, I'll go say L3 for short, we solved by substitution, which was like an algebraic way without a graph to solve a linear system. Today we're going to learn the third and final way to solve a linear system, and this one is actually my favorite. It's sometimes the fastest way, but depends on how the equations are set up, and we'll talk about that. But this is the last way, and it's also an algebraic method, so there's no graphs today. It's just going to be straight algebra, and we're going to be solving linear systems using elimination. We're also going to be verifying our solutions. You should always verify whenever you're solving equations, just to make sure you didn't make any small errors. Okay, the thing that we're going to be looking for here, so I'm going to have kind of a basic, a medium level, and then a spicy question. What we're going to be looking for is to match up in both equations two of the terms. So either the x terms or the y terms. So in this first more basic example, we can see both equations have a 3x. Okay. Once you see that two terms match, and sometimes they'll match already from the start, and sometimes you're going to have to make them match, like we'll see in example 2. Once they match, we can actually do something here that you probably never have done before. You can actually add or subtract the equations together. And I'll show you how to set that up. Okay. Here, we're going to subtract the equations. And you'll see why in a second. So I'm just going to rewrite them here, just a little bit bigger, so we have a little bit more space to see. The reason we want to subtract the equations from each other, and you want to set them up so that the equal signs are lined up. And I'm going to put a subtraction line there, and I'm going to put, actually, I'll use a different color. Set this up here, and I'm going to subtract the two equations from each other. So what I'm going to do is subtract 3x minus 3x, which is going to give me 0. I'm going to subtract 2y minus negative 5y. So 2y minus negative 5, it's like adding 5y actually. So that would be positive 7y. And finally, I'm going to subtract these two. And you put the equal sign just where it is. 19 minus 5 is going to give me 14. Okay. Now, the great thing here is we see that the x terms have been totally eliminated. That's why we call this elimination. So I'm going to just write this here because it's the first time we're doing it. The x terms have been eliminated. That's the whole point. Once your x terms have been eliminated, you can just solve for y. Eliminated. And the reason we chose subtraction here is because that's what would have eliminated the x's. If we would have added, we would have gotten 6x, which, yeah, that doesn't make them go away. So you want to kind of make them go to 0. So we subtract. Okay, so now that we have 7y equals 14, we're going to solve for y. So we're just going to divide both sides of the equation by 7. And we get y equals 2. That's one of our solutions already. That was really fast. Now what we do is use either equation to plug in that y value and solve for the x. So we're going to use equation 1. It doesn't really matter which one you use. You'll get the same answer no matter what. And we plug in y equals 2. So here's equation 1. And where the y is, we're going to take it out and put 2 since they're equal, and we want to solve for x. So we're going to have 3x plus 2 times 2 equals 19. Let's evaluate 2 times 2. It's 4. And then we're going to solve like normal using opposite operations. So the first thing I'll do here is subtract 4. I'll get 3x equals 15, and I'll divide by 3. And I'll get x equals 5. So there's my final answer. X equals 5, y equals 2. I always recommend you put your final answer at the bottom or wherever you finish so that the person reading it can find it really easily. Okay, to verify, I'm only going to verify on this one question, but I recommend on a test or a quiz you verify every single time. So here's equation 1. I'm going to take out the x and take out the y and put my two answers. So for x, I'm going to put 5. For y, I'm going to put 2, because that's what we think x and y are. I'll just remind you here, x, y. Okay, so this will be 15 plus 4 equals 19. Yeah, that makes sense. 19 equals 19. Perfect. First equation is verified. Let's do the second one. Okay, 5 minus 5 times 2. So we replace the x and the y with what we think they're equal to. Then this would be 15 minus 10 equals 5. Yeah, that makes sense. 15 minus 10 is 5. Perfect. So we verified that those answers are correct. Once you've verified, you can be absolutely certain you have the right answer. So that's the nice thing about this chapter, is you can always see if you have the right answer or not and go back and fix your mistakes if you have any. Okay, let's look at this question. Now, this one does not have any matching x or y terms. If we go back to the previous one, see how in yellow there I have the 3 x's highlighted? That's because those terms match. But in this one, none of the terms match. So what we're going to do is we're going to force 2 terms to match. So the 2 terms I'm going to force to match are the y terms this time. So think about to yourself for a second, what could I multiply this top equation by to make sure that the y terms match? And the answer is 2. So let's multiply that top equation by 2 and see what I get. So I'm going to get 10x plus 4y equals 12. You have to multiply every single term. If you multiply both sides of the equation by the same thing, you're not changing it. We're just writing it in a different way. Okay, now these y terms match each other, and we are this time going to add the equations together. So let's see how that looks. I'll add them together. 4y equals 12. Let's write the other one right underneath. You want to line up the equal signs exactly where they are. Okay, and this time we're going to add the equations together. The reason we want to add is because we want these 4y terms to get eliminated. So if I add them together, because they're opposite signs, one of them's positive 4y, the other one's negative 4y, then I will get rid of them. Okay, so first thing I'm going to do is add my 10x plus 6x. That's going to be 16x. Then I'm going to add positive 4y plus negative 4y. That's 0. And then finally, I'm going to add 12 plus negative 4, which is 8. So I have 16x equals 8. The y terms were eliminated. Then I'm going to just finish solving this equation by dividing by 16. I get x equals 0.5. That's one of my solutions. And I'm going to use that in either equation. I'll just use the second one this time. Doesn't matter. You can use either one. Equation 2. And plug in x equals 0.5. So it'll look like this. 6 times 0.5 minus 4y equals negative 4. So where the x used to be, I'm going to put the answer that we think it's equal to. So we'll have 3 minus 4y equals negative 4, and I'm going to use opposite operations now to solve for y. So first thing I want to do is get rid of the 3. So it's a positive 3, so I'm going to subtract 3 from both sides. That'll cancel it out. And I'll have negative 4 multiplied with y equals negative 7. And then I'm going to divide by negative 4. So I'm going to have y equals 1.75. Now you could write that as a fraction, or you can leave it as, you can write it as a decimal, it doesn't matter. But your final answer here would be, actually, let's write final answer. X equals 0.5, comma, y equals 1.75. And you could verify, and you should verify, but I'm going to leave that out just for time's sake here. But you could pause this video here and verify yourself that those are the solutions. Okay. And again, sorry, you could write them as fractions or decimals, doesn't matter. Okay, last question. We've got some fractions. We saw some fractions in the last lesson as well. What you want to do when you see fractions is get rid of them. You don't want to try and use substitution or elimination before you get rid of those fractions. So what you want to do is pick something that's going to cancel out any denominators in each equation. So in the first equation, we see denominators of 5. So we're going to multiply everything in the equation by 5. And let's see what we get. We would get 2x plus 5y equals 3. In the next one, we see denominators of 2. So we want to multiply everything in the equation by 2. So you'd get 2x plus 3y equals 10. Okay, so I would recommend you pause the video here and you try elimination on your own. But if you want to do it with me, we can go ahead and do that now. So what I see here is that the 2x terms both match. So I'm going to get rid of those by subtracting. So let's set up our equations like this over here. And I'll have 2x. And remember, you want to write everything in line so the equal signs are all in line with each other. And you want to subtract. Okay. So here, 2x minus 2x is 0. I'm not even going to bother writing the 0 this time. 5y minus 3y is 2y. And 3 minus 10 is negative 7. So divide by 2, and I've got my answer. And you can write this answer as a fraction, or I'm going to write it as a decimal. Y equals negative 3.5. Now we can choose either equation to solve for x. I'm just going to choose equation 1. I'm going to plug in, sub in y equals negative 3.5. So I'll have 2 times x plus 5 times negative 3.5 equals 3. So where the y was in the question, or in the equation, I'm going to sub in negative 3.5. Okay, so I get 2x minus, and 5 times 3.5 is 17.5. Now I'm just going to solve this by opposite operations. So I have negative 17.5, so I'm going to add 17.5 to both sides. I get 2x equals 20.5. I'm going to divide by 2. I get x equals 10.25. And again, you could write it as a fraction or a decimal. It doesn't matter. I'll accept both answers. So your final answer is x equals 10.25. Y equals negative 3.5. And this is the final answer. Okay, I'm just going to double check that that works really quick. Okay. Yep, perfect. Okay, and you can verify again, like I said, on the side, just plug those numbers in for x and y. I would recommend you use the original equations just in case you made a mistake when you're modifying them, when you're verifying your answers. Okay, that's the end of the lesson.